Hello and welcome to today's session. In today's session, we are going to have a look at types of machine learning. Supervised learning. Supervised learning is a type of machine learning algorithm that learns from labeled data. Labeled data is data that has been tagged with a correct answer or classification. Supervised learning, as the name indicates, has the presence of a supervisor as a teacher. Supervised learning is when we teach or train the machine using data that is well labeled, which means some data is already tagged with the correct answer. After that, the machine is provided with a new set of examples data so that the supervised learning algorithm analyzes the training data, set of training examples, and produces a correct outcome from the labeled data. Key points of supervised learning are: supervised learning involves training a machine from labeled data. Labeled data consists of examples with the correct answer or classification. The machine learns the relationship between inputs and outputs. The trained machine can then make predictions on new unlabeled data. The next point is types of supervised learning. Supervised learning is classified into two categories of algorithms. One is regression and another is classification. A regression problem is when the output variable is a real value, such as dollars or weight. A classification problem is when the output variable is a category, such as red or blue, disease or no disease. Applications of supervised learning. Supervised learning can be used to solve a wide variety of problems, including spam filtering. Supervised learning algorithms can be trained to identify and classify spam emails based on their content, helping users avoid unwanted messages. Image classification. Supervised learning can automatically classify images into different categories such as animals, objects, or scenes, facilitating tasks like image search, content moderation, and image-based product recommendations. Medical diagnosis. Supervised learning can assist in medical diagnosis by analyzing patient data such as medical images, test result, and patient history to identify patterns that suggest specific diseases or conditions. Fraud detection. Supervised learning models can analyze financial transactions and identify patterns that indicate fraudulent activity, helping financial institutions prevent fraud and protect their customers. Natural language processing (NLP). Supervised learning plays a crucial role in NLP tasks, including sentiment analysis, machine translation, and text summarization, enabling machines to understand and process human language effectively. Advantages of supervised learning. Supervised learning allows collecting data and produces data output from previous experiences, helps to optimize performance criteria with the help of experience. Supervised machine learning helps to solve various types of real-world computation problems. It performs classification and regression tasks. It allows estimating or mapping the result to a new sample. We have complete control over choosing the number of classes we want in the training data. Disadvantages of supervised learning. Classifying the big data can be challenging. Training for supervised learning needs a lot of computation time, so it requires a lot of time. Supervised learning cannot handle all complex tasks in machine learning. Computation time is vast for supervised learning. It requires a labeled data set. It requires a training process. The second type of machine learning is unsupervised learning. Unsupervised learning is a type of machine learning that learns from unlabeled data. This means that the data does not have any pre-existing labels or categories. The goal of unsupervised learning is to discover patterns and relationships in the data without any explicit guidance. Unsupervised learning is the training of a machine using information that is neither classified nor labeled and allowing the algorithm to act on that information without guidance. Here, the task of the machine is to group unsorted information according to similarities, patterns, and differences without any prior training of data. Unlike supervised learning, no teacher is provided. That means no training will be given to the machine. Therefore, the machine is restricted to find the hidden structure in unlabeled data by itself. You can use unsupervised learning to examine the animal data that has been gathered and distinguish between several groups according to the traits and actions of the animals. These groupings might correspond to various animal species. Groupings might correspond to various animal species, providing you to categorize the creatures without depending on labels that already exist. Key points of unsupervised learning. Unsupervised learning allows the model to discover patterns and relationships in unlabeled data. Clustering algorithms group similar data points together based on their inherent characters. Clustering algorithms group similar data points together based on their inherent characteristics. Feature extraction captures essential information from the data, enabling the model to make meaningful distinctions. Label association and assigns categories to the cluster based on the extracted patterns and characteristics. Advantages of unsupervised learning. It does not require training data to be labeled. Dimensionality reduction can be easily accomplished using unsupervised learning, capable of finding previously unknown patterns in data. Unsupervised learning can help you gain insights from unlabeled data that you might not have been able to get otherwise. Unsupervised learning is good at finding patterns and relationships in data without being told what to look for. This can help you learn new things about your data. Disadvantages of unsupervised learning. Difficult to measure accuracy or effectiveness due to lack of predefined answers during training. The results often have lesser accuracy. The user needs to spend time interpreting and label the classes which follow that classification. Unsupervised learning can be sensitive to the data quality, including missing values, outliers, and noisy data. Without labeled data, it can be difficult to evaluate the performance of unsupervised learning models, making it challenging to assess their effectiveness. Applications of unsupervised learning. Non-supervised learning can be used to solve a wide variety of problems, including anomaly detection. Unsupervised learning can identify unusual patterns or deviations from normal behavior in data, enabling the detection of fraud, intrusion, or system failures. Scientific discovery. Unsupervised learning can uncover hidden relationships and patterns in scientific data, leading to new hypotheses and insights in various scientific fields. Recommendation systems. Unsupervised learning can identify patterns and similarities in user behavior and preferences to recommend products, movies, or music that align with their interests. Customer segmentation. Unsupervised learning can identify groups of customers with similar characteristics, allowing businesses to target marketing campaigns and improve customer service more effectively. Image analysis. Unsupervised learning can group images based on their content, facilitating tasks such as image classification, object detection, and image retrieval. The next type of machine learning is reinforcement learning. RL is a branch of machine learning focused on making decisions to maximize cumulative rewards in a given situation. Unlike supervised learning, which relies on a training dataset with predefined answers, RL involves learning through experience. In RL, an agent learns to achieve a goal in an uncertain, potentially complex environment by performing actions and receiving feedback through rewards or penalties. Key concepts: agent, the learner or decision maker; environment, everything the agent interacts with; state, a specific situation in which the agent finds itself; all possible moves the agent can make is called action; reward, feedback from the environment based on the action taken. How reinforcement learning works. RL operates on the principle of learning optimal behavior through trial and error. The agent takes actions within the environment, receives rewards or penalties, and adjusts its behavior to maximize the cumulative reward. This learning process is characterized by the following elements: policy, a strategy used by the agent to determine the next action based on the current state; reward function, a function that provides a scalar feedback signal based on the state and action; value function, a function that estimates the expected cumulative reward from a given state; model of the environment, a representation of the environment that helps in planning by predicting future states and rewards. Main points in reinforcement learning. Input. The input should be an initial state from which the model will start. Output. There are many possible outputs as there are a variety of solutions to a particular problem. Training. The training is based upon the input. The model will return a state and the user will decide to reward or punish the model based on its output. The model continues to learn. The best solution is decided based on the maximum reward. That's all for today. Thank you for listening me patiently. So let's meet during the next video or during the next session.